So to begin our discussions on circles, I want to first talk about this special thing called tangents, or a tangent line. And so to begin our discussion on circles, though, we want to talk about some basic vocabulary. And so before we talk about tangents specifically, I need you to know that AC is called a radius. Hopefully you already knew that, sorry. And BC, if you go all the way across, is the diameter. So AC is just from the center to the circle, and then the diameter is a segment that goes all the way across the circle and includes the center. Now, the diameter is always going to be twice whatever the radius is, because the radius is halfway across. And so the radius is always half the diameter, or the diameter is always twice the radius. And I'm not going to spend too much time with if the radius is 2, then the diameter is 4, and things like that. M, right here, this is called a tangent line. And a tangent line is tangent because it touches a circle only in one spot. It intersects only in one place. Because the other option a line has is like the diameter touches a circle in 2 spots. Or this DE is a special line that we call a chord, and it touches in 2 spots. But if it only touches once, it is called a tangent line. And where it touches, point C, is called the point of tangency. Now this tangent line is always going to be perpendicular to the radius. That's very, very, very important, because perpendicular gives you right angles, and right angles give you right triangles and so forth. So if DE is a chord, C-H-O-R-D, not like a chord like a string, and then if you have it going through the circle, the whole line, you call it a secant, or a secant. So the difference between a chord and a secant is the difference between a segment and a line. Line goes all the way through, it's called a secant, touches in 2 spots. Line touches only once, it's called a tangent. A segment is called a chord, DE. Notice that a diameter is a special chord. So it is a chord, it just happens to include the center. Now, is it tangent, or if it's tangent? What I'm trying to say is, how do I know if something is a tangent, or if I do know that it's a tangent, what does it tell me? It's all about that perpendicular to the radius that I was talking about. Something is a tangent if and only if it's perpendicular to the radius. So that means if I know it's a tangent, I know it's perpendicular. If I know it's perpendicular, then I know it's a tangent. And now, perpendicular to the radius and on the circle is, because it could be perpendicular to the radius but not be on the circle. At a point on the circle is what I mean. And then if it's a tangent, then I have a right triangle. And if I have a right triangle, then it's a squared plus b squared equals c squared. And so that's our first example problem that we're going to do is this a tangent? So I have this radius marked right here, that's 5. And I have this segment right here, this tangent line, well, what looks like a tangent line, right, as 11. This part is 7. And then if this is 5, this right here also has to be 5 because it's a radius. And so really what we're looking at is this is 7 plus 5, which is 12. So if I want to see, is it tangent, is it a perpendicular? And so what I do is a squared plus b squared, and I see, is it equal to c squared? So I'm going to see is 5 squared plus 11 squared equal to 12 squared. And so far I put the question mark there, and really rather than the equals, let's just put the question mark there. So this is 25 plus 121, and this is 144. So 25 and 121 make 146, and we're oh so close. But this is not equal, and so this is not tangent. If it was equal, it would be a tangent. So this is not a tangent. Now, another thing you could do is you could answer the question, find the value of r if it is a tangent. So if it is a tangent, and I said circle C here, this is how we name circles. We put a circle with a dot in the middle and then C, just like we name lines and triangles and things like that. So if this is a tangent, then I know it's a right angle. This right here is 6, just that part. And so if this is r, this is also r. And so this whole length of the triangle, the hypotenuse here, is r plus 6. And so I'm going to do a squared plus b squared equals c squared, because it's a right triangle. My a squared could be the r squared right here, plus 10 squared, equals r plus 6 squared. And you have to be careful when you square this right here, because squaring, we cannot distribute it. It doesn't work. We'll leave that conversation for another day. But what you have to do is r plus 6 times r plus 6. And so you FOIL it out or distribute it, whichever word term your teacher uses. So r squared, 6r and 6r. And so that gives you 12r, because you get r times 6 and 6 times r plus 36. So now you're like, oh no, r squared showed up. Yes, they did, but r squared, if you subtract r squared from both sides, they drop out. Then subtract 36. Subtract 36, you get 12r equals 64. And then you take 64 and divide it by 12. And, well, we could take out a 4, right? Take out a 4. 64 divided by 4 is 16. 12 divided by 4 is 3. And you get 16/3. Or r is about 5. 15 divided by 3 is 5. So 5.3 repeated. And there you have it, what the radius of your circle is. And so it all belongs to, if it's tangent, then it's perpendicular to the radius. And then you have a right triangle, so a squared plus b squared equals c squared. The other thing I want to talk about is if you have a common external tangent. If this point C is where they intersect, a tangent line and a tangent line, I know that that line, CB, is congruent to this line, CA. I'm not going to get into the reasons why, because I want to take the time to prove that in class. But it has to do with drawing in this radius and proving some triangles congruent here. But how we can use it is that this point will always be the same distance from that point and that point. And we call it a common point that the tangents have in common. So, if both of these are tangents, then I know that this is equal to this in length. So I know that 3x is equal to x plus 3. And then I can solve it. I could subtract x from both sides. I could get 2x equals 3. And then I could divide by 2. And then suddenly x equals 3 divided by 2, or 1.5. And that is how you find x in this case, because we set them equal to each other. Big time, you can make these equations more difficult. You could include x squareds in there. You might have to solve quadratics, and so it can become more difficult. But I just wanted to show you how straightforward it can be, depending on the equations.